So this video is it's the solution to Chem102, the acid-base equilibria homework number 2. I thought I'd make a video because there's a few details that I'd like to point out. So this is a problem right here. You can look at that. You should have that already. And what we're going to do is, let's look back at the problem real quick. What's happening here is we have a solution of a weak acid, nitrous acid, and then we're adding a strong acid to it. What we're doing here is we're first going to establish an equilibrium with the weak acid, normal ice table. Then we're going to disturb that equilibrium by adding some H+ protons. Well, Chatelier's principle says that if we add the protons, which are a product to the right side of the equilibrium, it's going to shift it to the left. We're going to figure out where everything is at the end after everything's been shifted. So our first step is to do a normal ice table for the equilibrium of nitrous acid before we add the hydrochloric acid. So there we go. That's the ice table. That's what I get for X. Check that. Make sure you guys get the same thing. Now, okay, for our new equilibria, the one that's well before it's comes back to equilibrium when it's been disturbed, our initial concentration of nitrous acid will be what we started with, 0.493 minus what we lost. And then, okay, look at this. Because we're adding 15 mils of hydrochloric acid, we have to do a dilution calculation. So, M1V1 equals M2V2. Solve for the new M2. 100 over 115. 115 because we add 100 mils and we added 15 to it. And there's our initial concentration of nitrous acid. Now for nitrite ion, we had 0.0138 molar, and we're doing a dilution for that. And then that's our new concentration. That's molar. Well, now, for the proton, we have to do a couple things. First, okay, there's the concentration of H+ that we had from our initial equilibrium. And what we're going to do is multiply that times the volume that we had to get the moles. This is moles right here. Should put moles down there. Of H+. And from the hydrochloric acid, we have 15 mils or 0.0150 liters, and it's 0.50 molar. So we have this many moles of H+. So we add those moles together. That's how many moles initially we have of H+ down there in that beaker. And the volume is 115 mils or 0.115 liters. So our concentration, our initial molarity of H+ will be 0.0772 molar. All right, got all that? Now, we're going to set up our second ice table where our initial concentrations are what we just calculated. And also, we know because we added some H+, what Chatelier's principle says the equilibrium is going to shift that way it's going to shift that way to get back to equilibrium. It's going to be minus X here and minus X here, whereas plus X over here. So there's our equilibrium expression right here. Solve for X, get X is 0.0095. Now remember, the question asks for the equilibrium concentration of nitrite ion. So we have to come back and subtract our X from this number right here, which we do right here. And there's your answer.